Hi, everyone. This is your professor, Dr. English Dowdell, and welcome to Module 9, Arrays. So in this lecture, we're kind of look at one of the most powerful and practical topics in programming, which is arrays. Now, if you ever tried to keep track, say, of a list of things, like your weekly grocery items, daily temperatures, or your friend's phone number, then you've probably already understood why arrays exist. Now, by the time we finish this lecture, you'll know exactly what an array is, how to create one in pseudocode, and how to use loops to process and work with arrays efficiently. So let's get started. Okay, so let's start with a simple question. Now, what if I ask you to write a program that stores the temperatures for each day of the week, Monday through Sunday? Now, you might be tempted to do something like this, declaring Monday temp, declaring a Tuesday temp, declaring a Wednesday temp, and so on. And then you'd have to read each one, you'd have to add them up, and then you'd have to calculate the average. Now, as you can see, that's 7 variables, 7 inputs, and 7 lines of logic. Now imagine if you had to do this, say, for an entire month. That's 30 days. Now, would you really want to create 30 variables? Of course not. Okay, that's where arrays come in. So arrays, they let you store a group of related data items like all of your temperatures under one variable name using an index to tell them apart. So let's define it clearly. An array is a collection of variables of the same type stored under one name and accessed, like I said, using an index. So think of an array as a row of boxes, okay, each holding a value. So let's say you want to store maybe 5 temperature values, okay? You could declare it like this in pseudocode. So this means, hey, computer, reserve space for 5 numbers called temperature. Now each box is numbered, but not with the days of the week, but with the index that starts with 0 or 1, and depending, that depends on the language or the logic convention. Okay. Now in our pseudocode, we're going to start with 0. Okay, index 0, because that's really the standard in most programming languages. So it would look something like this. Like I said, you'd have your row of boxes numbered with the index 0, 1, 2, 3, 4, and each one would hold a value. Okay, so let me make this a little bit more relatable. So imagine a row of mailboxes, okay? And each mailbox has the same label, temperature, okay? But each one has a number, box 0, box 1, box 2, so on, okay? Now, when you want to store, say, the Tuesday's temperature, you might put it in mailbox 1, okay? When you want to read the maybe Friday's temperature, you would open mailbox 4. Okay, so instead of naming 7 separate mailboxes, you just have one group name, temperature, and then you use the number to reach the right box. Okay, so now once your array is declared, okay, then you can store or either access the individual elements by using that index. So here's a quick pseudocode example. So we're declaring temperature and we're reserving 7 spaces, okay? And we're saying we're going to set the temperature of the first one, which is 0, the index 0 to 72. We set the index 1 to 75, index 3 to 71, so on and so forth. Okay, now each position in that array is going to hold one value. Okay, now if I wanted to say display the temperature for Thursday, which is this one here, then all I would just say, I'd have like an output and I could either call the temperature, call the value directly, or I could call the value, say, in a sentence. Like I could say, like, Thursday's temperature is, and then temperature 3, okay, with the index of 3. And then my output is, if I go to 3, my output is whatever the stored value is of index 3, which is 69. Okay, so instead of having to, again, having to have various different variables, I've got one variable that's indexed, and then all I have to do when I want that particular variable, I want that particular, item, then just call it by the index, and I can get that value. Now, one thing I want you to remember is that arrays can store multiple values of the same type. Okay, it has to be the same type. So that means you wouldn't mix numbers and strings in the same array, because then it would get confusing to process it later. Now, typing all 7 of those set statements like I showed in the previous screen is fine, if you've got like a short list, but what if you had like 30 or 100 or even like 10,000? This is where we can use a loop to make this a little bit more efficient. So this is how we would ask the user for, say, 7 temperatures using a loop. So we declare our array, okay, like we did before, but then we use the for loop, and then we say counter equals 0 to 6 because we're wanting 7 of them. Remember, 0 is our first position. So for the first one, we go through 0 to 6, and then we're saying we're going to output and ask the user to enter the temperature for the day, and then have the counter here, and then we're going to input whatever that temperature index is, okay, into this array variable, okay? And then enforce. So instead of like repeating the same code 7 times like we did before, with the set, the loop automatically steps through each element in the array. And every time the loop runs, it's going to ask for one more temperature and then store that in the next box. And this is what makes arrays more powerful, and loops a powerful combination. Okay, so this is just basically sort of like the flow of it. Again, we set the counter to 0, and then here we're checking that the counter is less than or equal to 6, because once it passes 6, that's giving us more than 7 positions, okay? So we're saying if it's less than 6, then yes, we're going to output, this statement, and then we're going to input and add the counter, so it's temperature 0. Okay, and then what we do here is we're going to say we're going to add 1 to that counter. So then that's going to make that counter 1. Okay, then we come here and we say, is the counter less than or equal to 6? If it is, then we keep going. And we're going to keep going until this makes it 7. And once we come here and now that counter is equal to 7, it's no longer yes, it's going to be no, and we're going to end it. Okay, so this is where, again, every time the loop runs, we're, asking for one more temperature, and then we're storing it in the next box there. Okay, and again, this is what makes that combination of arrays and loops really powerful. Now, once we have all our values stored, okay, we probably need to do something with them, like, calculate maybe an average or something like that. So here's an example of that pseudocode. Okay, so let's walk through what's happening here. So we declare, of course, the temperature that's holding what? 7 values here. Okay, and then we're going to initialize total, the variable total, to equal 0. And then this loop is going to run 7 times. And each time we're going to ask for the temperature, we're going to store it, and then we're going to add to the running total. Okay, so this is us adding to the running total. Now, this is important to have, because if you don't have this where you're adding to that running total, I think we talked about this in a previous lecture, then you're going to get in that infinite loop. Okay, so we've got to increase that. We've got to increase this total. Okay. Now, after the loop finishes, then what we're going to do is we're going to divide it by 7 so that we can what? Get the average. And then finally, we're going to display the result. Now notice that we only needed one loop and one variable name for all 7 values. And again, that's the power of the array. We only need one variable name here. Okay, now before we go on, I want to help you trace the logic. Okay, we're going to trace the logic together because for a lot of beginners, this part is often kind of confusing. Okay, so suppose, for instance, we had this. Okay, we had the pseudocode that we just previously walked through, and the user entered the 7 values as 72, 75, 71, 69, 70. 74. Is that 7? Yeah. And then 73. Okay. So these are the values. This is the temperatures that they enter. So this is what happens during each iteration. So again, we're going through this loop. So we declare again, it starts as 0. So here's 0. The first input is 72. Okay. So that's our first input. And that's the counter is 0. Okay. So they input 72. And then the total would be 72. Okay, so that's the total. So the total plus whatever, this value is. Okay, so we go through the loop again. So the next time we go through the loop, we're going to, it's going to be 2 because we're saying 0 to 6. So I'm sorry, it's going to be 1 because we're saying 0 to 6. So the next one is 1. They input the value of 75, and then we add that's 75 to what the existing total was 72, and now we've got 147. Okay, then it loops again. The counter becomes 2. The input value is 71, and then when we add that to the total, it's 218. So we keep going like that. Okay, so that's what happens with this loop. You're going through. I want you to see how it's traced. For each counter, every time we increase the total. Okay, every time we have an input, they give us an input, and then here in this line here, we're adding whatever that input is that they gave us. Okay, we're adding it to the existing total. Okay, and this is the existing total until we get all the way down here to 504, and that's the total once we get out of this loop. Okay, so once we end up out of the loop, the total is 504. We divide that by 7, and then we get the average, and then our output is the average temperature is 72. Okay, so again, this is how, if we're tracing, as far as I just wanted to show you how we actually work through this loop. Okay. Okay, so let's look at another common array problem, which is finding the highest value. So you'll see this in your assignment if you pick the quiz score scenario. So, take note of this. So here's the logic in pseudocode. Okay. So let's kind of walk through this a little bit. So the first thing that we do is we're declaring the variables. Okay. So score 5 is going to create the array with 5 boxes so that we can store the quiz scores. Okay, the valid index positions, remember, going to start with 0 because that's what we're starting with. So it's going to be 0, 1, 2, 3, and 4. Okay, so again, think of it like this: score 0, index score 1, score 2, so on and so forth. Okay. Now, the highest, this is a single variable that will eventually hold the highest value that's found in the array. Now, the next thing here is we're getting the input from the user. So we've seen this loop statement before on previous slides. This loop is going to run 5 times, once for each element in the array. So basically, this is what's gonna happen like each time the loop runs. So the counter is gonna be counter 0 to 4. Okay. And for the first one, it's going to display, enter quiz score. And so then the person will enter a score. And then it'll run again, for 1, for 2, for 3, and for 4. Okay, and it's going to ask them for quiz scores. So when they finish, after the loop finishes, the array should look something like this. Okay, so for score, the first score, which was 0, okay, index 0, we got a 78. We got an 85 for the second one. We got a 92 for the third one. We've got an 88 for the fourth one. And we've got a 79 for the fifth score. And again, don't get mixed up. We always start with indexing of 0, okay? Now the next step is initializing the highest value. So here we set highest to score 0, okay, which is 78. Now we always need a starting point before we can compare anything. So basically this line here just kind of says, assume that the first score is the highest until we find something higher. Okay, so right now, highest, the variable highest, is going to be storing the value of 78, right? Okay, so now next what we're going to do is we're going to compare each score so that we can find the highest. Okay, so the program, we have a loop again. So the program is going to loop through the rest of the array, starting with index of 1. Okay, um, and because we already know the index 0, we've got that as the starting point. So we're going to start with 1 this time instead of starting with 0, because we already have this, we already know what, have that as the starting point. Okay, now each time this loop, okay, each time it goes through the loop, okay, it's going to check, is the score higher than the current highest score? Okay, so right now the current highest score is what, 78. And so we're going in and we're saying score counter 1, okay, index 1. Is that greater than the highest, which is 78? Then if it is greater, then we're going to set that as the highest. Okay, so let's kind of walk through that. So right now 78 is the highest. We go in and we say score 1. Okay, index 1, is it greater than the highest? So is index 1, which is 85, greater than the highest, which is right now 78? So yes, it is. Okay, so then that's going to become the highest. Okay, we're setting that now as 85 as the highest. Then we're going to loop again. Now we're looking at score index 2. And we're saying if score index 2 is greater than the highest, which is now 85, then we're going to set score index 2 as the highest. And yes, it is greater. Okay, so now the highest is set to 92. Okay, we go through the loop again. Now we're looking at score. We're 1, 2. We did 1, 2. Now we're at 3. So we're saying if score counter 3, okay, array 3 is greater than the highest, which is 92, then we're going to set that to the highest. But 3 is only 88. It's not the highest. So now we're going to ignore this. Okay, we're not going to set it because this statement is false. Okay, and then we go through the next one. Okay, so now we're at 4. Okay, and we say, okay, if score 4 is greater than the highest, which is 92, okay, that's the value that's in there, then we're going to set that score 4 to the highest. But score 4 is 79. It is not greater than 92. So therefore, this gets ignored because this is false. Okay, and so now the highest is 92. Okay, highest is equal to the value of highest is 92. So now we're through with our loop, okay, because we went through 1 to 4. Now our output is going to be the highest score is 92. Okay. Now, some of the mistakes that I want you to avoid are some of the mistakes that could possibly make, because again, this is going to be similar to what you're going to, if you choose this particular scenario. The one mistake that I see is forgetting to initialize the highest. If you don't set the highest, to equal, like, say, the first score, then it might start as an empty, it might start as empty or 0, which could cause some incorrect results. And then starting the loop at 0 instead of 1. Some people will start it at 0 here instead of the 1 in this comparison loop. And so what's going to happen is you're going to end up comparing the first element to itself unnecessarily because, see, we've already set the highest to 0, so we don't need to compare it to itself, okay? And then another thing that I see a mistake in is using the wrong comparison operator. So this greater than is going to help find the highest. But say if you were looking for the lowest, then you would use a less than sign. So, in your assignment this week, you're going to apply this same logic pattern. Okay, but depending on your chosen scenario, you might be calculating maybe an average or total or count instead of finding the highest value. Okay. Another thing is you might wonder why we don't do all of this in one loop. I mean, you could, as long as you initialize the highest to the first element after reading it, but separating the loops makes the logic a little clearer for beginners. Okay, so here's another pattern that you might see often, counting how many times something happens or exists in an array. So for example, imagine that we have 10 survey ratings from users, okay? And the values of the survey ratings is value 1 through 5, like 1 star through 5 star. And we want to count how many users gave us 5 stars or 5, okay? So again, same as we did before, we declare our array with 10 positions because again, like I said, we've got 10 surveys. And then we're counting up. We want to count how many fives, how many ratings of 5 that we have. So first, we're going to go in and we're going to loop through the array once to be able to fill it. Okay, so we need to fill the array with all of the scores. So we're going to fill it, 0 through 9, which is going to give us those 10 scores. Okay, and then we're going to loop again so that we can process it. Okay, so here we say if rating counter is equal to 5, then we're going to count it. Okay, so we're going to count it. And then we're going to keep counting. So as we loop through each one, if it equals 5, then we're going to add it to the existing count. You remember we start here with an initial of 0. So if we go through, say, the first one, okay, then that's going to be 0 plus 1, and now that's going to take our count to 5. Okay, so we go through the second one, maybe that's not 5. We go through the third one, that's not 5. We go through the fourth one, oh, that's a 5. So then this becomes true. So then we add another number, another count, another 1 to the existing count. Okay, and then we keep counting, and then in the end, this is going to hold how many times that rating counter's value was equal to 5. Okay, and then we're going to output number of people who rated 5 is equal to that. Now, in more advanced languages, you might fill and process in a single loop. Okay, but for now, this pattern kind of helps to keep the logic organized. So when you're doing your assignment, and you've got to do something like this, separate it out into 2 different loops, okay, so that you don't get too confused. Now let's talk about some of the common mistakes that students make with arrays. So one is off by 1 errors. That means forgetting that arrays start with 0, okay, and trying to access, say, index 7 in a 7-element array. Okay, everything starts with 0. So you got to kind of put your mindset into that when you're programming, that it starts with 0. If you declare, say, a temperature 7, then your valid indexes are going to be what? 0 through 6, because 0 is going to be that first index, okay? The second one is forgetting to initialize values. If you perform some kind of math on an element before it's actually been assigned, the result can be kind of unpredictable and you might get an error message. Okay, and the next one is incorrect loop boundaries. Your loop should go from what, 0 to whatever the array size is minus 1. Okay, so for instance, if we had an array that was 7, okay, entering it like this would not be correct, 1 to 7, but entering it 0 to 6. This is correct. You know, the smallest adjustment is going to prevent a lot of runtime logic errors. Okay. Now, sometimes we don't need to ask the user for input like what we've been doing in our previous examples. Okay, maybe we already know the values, like maybe product prices or something like that. So in this case, we can initialize the array directly, okay, like this. So we, instead of asking for, say, the values down in a loop statement, we initialize the array's values here. Okay, this is how we do this. Okay. And this is often used when, say, data is fixed or the data is small. And if you choose to use something like this, you know, with your scenarios, that's fine. Okay. Um, but this is how that works. Instead of you asking the user like we were doing before, you know, using an output asking a question, we'll initialize them here, and then we'll use these values, you know, within our logic. Now, I want to help you practice through thinking through this, okay? So imagine that we're creating a simple grocery store list calculator, okay? Um, we want to store the prices of 5 items, and we want to find the total, okay? So before you even start writing pseudocode, you need to kind of reason it out verbally, okay? So we need to store multiple prices, okay? So we're going to use this array price 5, okay? Because we're going to be storing what, 5 items, okay? And then we're going to loop through each item to get the price, okay? Then we're going to add each price to get a running total. And then finally, we're going to output the total, okay? All right, so here's our pseudocode. Okay, so we store the 5 prices and compute the total. So we've created our array here. We've got our total, which is a variable, and we initialize that to 0. Then we're going to collect the prices from the user. So you've seen this. We've done this on a few slides. For counter 0 to 4, we're going to output, you know, to ask like the price. Okay. And then we're going to input that and create that particular index and give it the value that the user provided for us. Then we're going to add up all the prices. So for counter 0 to 4, we're going to loop through it, loop through each one, 0, 1, 2, 3, 4, and we're going to keep adding the value of that array every time we loop. So price 0, we're going to add to the total, which initialized as 0. Then we go to 2, go to 1, index 1. We're going to add that to the existing total. And then we're going to loop through and add 2 to the existing total, add 3 to the existing total, add 4 to the existing total until we have all 5 of the prices added together in this total. And then we're going to show the result. Okay. So, like I said, what we've practiced already, this you should start seeing some similarities. Okay. This is the logic that's going to help in your assignment, say if you choose that grocery store scenario. Okay, here's something I want that I think is interesting to think about. So arrays store data in contiguous memory, meaning that all the boxes, they sit right next to each other in the computer's memory. Okay, that's why we can quickly access any element just by its index. Now, this is different from, say, a list of files that are scattered across your desktop. An array is neat and organized, like numbered file folders sitting side by side. you don't have to understand the deep technical details yet, but it's just kind of helpful to know why arrays are really so efficient. Now let's take a moment to appreciate what we've learned so far. So now you know how to declare arrays in order to store multiple values, use loops to fill or process arrays, calculate totals, averages, or counts, and then retrieve and display specific elements. Now, this combination of arrays and loops, like I said, is one of the most powerful or common patterns in programming. Okay, it shows up in almost every language that you'll ever use. Now, if you want to challenge yourself with the optional Python extra credit this week, you'll see that arrays in pseudocode translates to lists, okay, in Python. So here's an example, a side-by-side comparison. This is the pseudocode, and this is the Python. And then if you want to find the average, this is the code for doing that. Now, notice how Python makes some of this easier. But the logic is still the same. It stores, it processes, and it outputs. Okay, so let's pause and practice with, again, sort of like this exercise. So I want you to say aloud, if I had an array of 5 test scores, what steps would I have to take to find the average? So I want you to think through this, okay? So one is we're going to create the array, okay? We're going to get the scores. We're going to add them together in a loop. We're going to divide the number by 5, and then we're going to display the result. Okay, so I want you to take a moment, think about that, and I want you to see if you can write as far as the pseudocode for that. Okay, so pause this video and go ahead and try practicing writing the pseudocode for that. Okay, now if you've got that, let's show you the answer. So again, we're going to declare our variables, one of which is going to be the array. We're going to, so that's creating the array. Then we're going to get the scores from the user. So we've seen this in previous slides. Okay, this is how we get the score from the user. Then we're going to add them together using a loop. Okay, then we're going to divide the total by 5, and then we're going to display the results. Okay, so here's a little challenge just to check your understanding. Okay, so look at this pseudocode here. Okay, and you see we're adding the numbers here, so we're not asking the user for the numbers, so we're adding the numbers here. Okay, and I want you to try to predict the output. Okay, what will be displayed? Okay, so let's trace this. Okay, so the first time we go through the loop, okay, what will the variable I be equal to, as for the for I is equal to, okay, and then what is total equal to? So the first time, of course, because we're saying 0 to 3, I is going to equal to 0. And then the total is going to be 3 because the index, okay, 0 for num is 3. Okay. All right. So num I, if this is 0, then this is 0. Okay. Remember, it starts here. That's going to be equal to 3. So your total is going to be equal to 3. Okay. So we do the loop again. What's the next one? What's the next? If I is equal to what? 1, then what's our total going to be? Okay, it's going to be 9 because why? Because we're saying that I is equal to 1. Okay, this is the position for 1. This is the array position for 1, which is 6. So now we're adding 6 to the total. Remember the previous total was 3. So now if we add 6 to 3, now we get 9. Okay, now we loop again. What's the next one? So if we're now on the index of 2, where I is equal to 2, what's total? Okay, so total's 18. Again, what are we doing here? So 2, we're saying index 2, which is 9. Okay, and our total so far, the previous total was 9. Okay, so we're adding 9 to 9. Okay, and that's what's giving us 18. Okay, one more loop to go through. So what do we predict? So the next one, the index is 3. So what's that total going to be? 30. Okay, and again, the reason why it's 30, it's 12. So the last one is num3, which is the index 3 of num, the array, is 12. So now we're adding 12 to 18, which was the previous total, 18 plus 12. Now that makes our total 30. And so our output is 30. Now you might be wondering, why an array is such a big deal. Again, it allows us to handle data efficiently and dynamically. Now, without arrays, we'd be stuck in writing the same logic over and over again for each variable. Arrays prepare us for sorting and searching data. It helps us in managing records and databases, processing user inputs, and handling files and spreadsheets, and building apps and games that track multiple objects of users. They're used just about everywhere. So let's recap everything we've covered today. So arrays are what? A collection of related data items stored under one name. Okay. Each item in an array is accessed by an index. Loops are used to populate and process arrays. Now you can use arrays to say what? Calculate sums, averages, find maximums, and count occurrences. Understanding arrays, that's going to help build the foundation for more advanced structures like lists and dictionaries and objects. Okay, now here's your reflection question that I have for you. Okay, think about a real world situation where you need to keep track of several pieces of similar data, maybe daily steps, monthly expenses, or favorite songs. Now, how would an array make that task easier? Now, you'll use that kind of reasoning as you write your pseudocode for the assignment this week. Okay, so for this week's assignment, you're going to demonstrate your understanding of arrays by writing pseudocode that stores and processes multiple values using a loop. Okay, so you're going to choose a scenario that involves storing and working with a list of values. So it could be daily temperatures where you're storing 7 temperature values, then you're going to calculate the average. Um, it could be student quiz scores where you're going to store 5 quiz scores and display the highest score. It can be a grocery list where you're going to store the prices of 5 items and calculate the total cost. Or it could be survey ratings where you store 10 user ratings, 1 through 5, and count how many gave you a 5. Now, I've kind of helped you through some of this, so don't just copy the code that I've presented in the lecture. I want you to understand what each one is. So writing your pseudocode, it needs to include an array declaration to store the values. Okay, so I showed you how to do that. A loop that populates the array with user input, or you can use sample values. Remember how we initiated values, so you can use either one. Um, then it should include processing logic to do something with the array, like either you're going to do a sum or an average or a max or a count or something like that. And then you're going to output the final result. So for instance, like what the total or the highest or the count of a specific value or whatever. Now, I want your pseudocode to include clear variable names. So use clear variable names. Include a loop to process the array. I want you to include comments to explain your logic. So again, don't just copy what I have. I need to see comments so that I know that you understand, what each step is doing. Okay. And then I want you to reflect the correct order of operations. So it should have the correct order of operations within your pseudocode. Okay. Now, if you need some help, if you review chapter 8 in your textbook, and then the class examples that I've showed you with arrays, with loops, that'll help you. And then again, I've got some videos and things like that and some references and resources for you as well. But you can always look back at this video for how to use arrays in pseudocode. So you're going to upload a document containing your pseudocode and a brief label at the top with whatever your chosen scenario was. Okay. Now, if you choose to do the extra credit as far as the optional Python enrichment, basically you're just going to create the Python version of the assignment. Okay. So use a Python list to store the values like the scores or the temperatures, and then calculate and print the results. Okay. All right. So again, that's what you have to do this week. So this wraps up our lecture on arrays. So again, be sure to review chapter 8 of the textbook. Rewatch this video if you need to, okay? And then practice writing like small snippets of pseudocode on your own, okay? I even have an optional practice in the course room if you want to practice writing as far as Python arrays. Okay. Remember, the more you trace and test your logic, the easier arrays are going to feel. So again, like we did a couple of trace testing, okay, where we said, okay, the first loop, this is what it's going to result. The second loop, this is what it's going to result. If you do that, as you're writing your pseudocode, um, just to kind of get an idea of what the results are going to be for each loop, that's going to help you. That's going to make it a lot easier. Rays are going to make a lot more sense to you. Okay. All right. So um, we'll start working probably next week, I believe, with files, which we often use like arrays behind the scene to kind of manage large amounts of data. I believe that's what we're going to be working on. But um, like I said, if you have any questions, please reach out to me this week. Until then, happy coding. And again, as always, if you get stuck, reach out early. All right. Thank you.